We also learned what is meant by a solenoidal vector. Solenoidal vector means if divergence of a vector function is 0, then the vector function is said to be solenoidal. One example we can think of is in electrostatics we come across what is known as the magnetic field. Divergence of a magnetic field is always 0. So a magnetic field is an example of a solenoidal vector function. In mechanics, we also have what is known as a conservative force. In fluid mechanics, we also have what is known as an irrotational vector. So, an irrotational vector or a conservative force can be defined with the help of or can be understood with the help of the operator curl. Any motion in which the curl of the velocity vector is 0 is said to be irrotational. If curl of velocity vector of a motion is 0, then the motion is said to be irrotational. In fluid dynamics, if V bar represents velocity vector of a flowing fluid and curl V bar is equal to 0, then the flow is said to be irrotational. Similarly, if a force represented by F bar is such that curl F bar is equal to 0, then F bar is said to represent a conservative force. F bar represents a conservative force. So curl F bar is equal to 0 can be interpreted in two ways. F bar can represent an irrotational vector or F bar can represent a conservative force.